Let's look at the solutions to the questions now. In the figure given below, shows the triangle ABC that circumscribes a circle of radius 3 cm. D is the point of contact of the circle with side AB. AD is equal to 4 and BD is equal to 6. What is the ratio of AC to BC? We need ratio of AC to BC. Okay. First thing, because this is 4, up until this point it will also be 4 because this is 6. Up until this point it will also be 6 because the length of tangent drawn from an external point are equal in length. This is what we know. So this is A and this is A. Now we have information about in radius and we need ratio of lengths because we need ratio of lengths and we have circle about in radius. Okay, so we'll have to do this. I know area is given by in radius into semi-perimeter, and this is also equivalent to under root semi-perimeter minus A. A is one of the three sides, S minus B, S minus C. This I know. Okay, so 3 into semi-perimeter here will be 6, 4, 6, 4, AA. 10 plus x is equal to under root 10 plus x into, x. Why am I using x when I've already used a? So a, and a, and then 4, and then 6. As soon as I get my A, I will have the ratio of AC and BC. Okay, so this is 3 times of 10 plus A is equal to under root 24 times of A times of 10 plus A. This 10 plus A and 10 plus A, that is common. You can get rid of it. 3 is equal to under root of 24A by 10 plus A. Basically, this 10 plus A I cancel. I'm left with root here. Take it to the other side. This much I will get. This I can turn into 9 is equal to 24A by 10 plus A, which gives me 90 plus 9A is equal to 24A. Is this correct? Okay. Which will give me 15A is equal to 90 or A is equal to 6. If A is equal to 6, AC will be equal to 10 and BC will be equal to 12. So the ratio they will have is 5:6. Okay. Next, a trapezium with parallel sides 2 and 12 is inscribed in a circle. If the height of the trapezium is 12, then what is the perimeter of the trapezium? I have some shape like this happening, in which this is 2, dropping perpendiculars. Height of the trapezium is 12. So this is 12, this is 2. This entire length was supposed to be 12. Because this is 2, this has to be 5 now. This has to be 5 now. Will get equally distributed on either side. This is 12, this is 5, this is 90. So this turns out to be 13 now. Same way, this turns out to be 13 now. So I have 13 plus 13, 26, and 12 plus 2, 14. Adds up to a total of 40. Answer is option D. Next question, the diameter of a circle is thrice the side of a square. So we know 2R is equal to 3A. Find the ratio of area of the circle to that of the square. Area of the circle is pi r square and that of the square is A square. So pi r square, A is 2R by 3, no? So 2r by 3 whole square. So this will go to 9 pi by 4. R square will get cancelled. Option B should be the answer. Next one. The given points a plus b, c plus 2a minus b, b plus c, c plus a, and c plus a to c are vertices, blah, 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 blah. Okay. Painful question. Best thing to do here is let us assign values to them. If I had a, b, and c as 1, 2, and 3, then the points that I'm dealing with would be a plus b is 3, c plus 2a minus b would also be 3, b plus c would be 5, c plus a would be 4, c plus a would be 4, 2c would be 6. Okay. Now, they're definitely not collinear. They're definitely not collinear because from 3 to 5 to 4, it should go up, it should go down. But it is going up, going up, going up. So they're definitely not collinear. Now, in order to differentiate between these three, all I have to do is find out the length of the sides. So let's call this point M, this point N, and this point P. Mn would be equal to 3 and 5, so 4, 1, so under root 5. Mp would be equal to 3 and 1, 3 and 4, so 1, 3 and 6, so 9, so under root 10. And Np would be equal to 5 and 4, 1, 4 and 6, 4, so under root 5. Okay, okay. So look at this. Now we simply have to look at the relationship. Mn square plus Np square is indeed equal to Mp square. This relationship is only valid in right angle triangle. So answer has to be option C. Next question. A building consists of a hemispherical dome on the top of a cylindrical wall. Okay, hemispherical dome, the top of a cylindrical wall. Okay, hemispherical dome on top of the cylindrical wall. The outer radii of the dome, is 7. Oh, everything is 7. The outer radii of the dome and the cylindrical wall. This is also 7. And the height of the wall. Is also 7. What is the cost in rupees of painting the outer surface of the building at the rate of 20 rupees 20 per square meter? Okay. So the thing, we need surface area. For the cylinder, the external surface area will be given by 2 pi RH, one circle with the height, and for the dome, it will be given by 2 pi r square. This is the total surface area, and this has to be multiplied by 20. Now, good thing is because R and H are both 7, I can happily replace this by 49. For this hemispherical dome, it is also 49. So I've got 196 into 22 by 7 here. Cancel, 28 into 22. This whole thing has to be multiplied by 20. 28 into 22 is 25 square minus 3 square, so 616 into 20. Or the final answer here is 12320. The answer should be 12320. That will be all for this episode. Hopefully you learned something. Okay.